Karl is a member of the Big Bluestem Audubon Club in Ames, and a very active birder, and retired from the National Weather Service. And his knowledge of how to use the radar and interpretation is just phenomenal. So I'm happy to give you Karl to start his talk.
All right, thank you.
You're welcome.
I hope you all can hear me well. It's fun to be here. I'll just say, normally you'll see me with glasses on, but with the glare, and I can see a computer screen actually better with them off, I'm just going to leave them off. So if you see me out on the street, I'll have glasses on. So I will share my screen and we'll start right in here tonight. And I didn't see anybody of you with a beer, but if you want to get a beer, that's fine with me. St. Patty's Day. So what I'd like to talk about tonight is birds and weather, and especially migration. And this is a great time to give this talk because migration is starting. Definitely last night was a good migration night, and we'll be continuing with that, especially through, obviously through March and April and May, big migration time. So we've got weather maps to show you and a few pictures of birds as well. So this is a radar loop, and this is what we're talking about as far as what you can see and how you can really get a feel for migration in action by looking at this is called a composite radar loop, basically, or a mosaic of radars, and it puts together all the radars from the National Weather Service sites all across the country. So there's, I can't remember, 130 some of them, I think. So every one of these circles that you see is a radar location. So Quad Cities, Davenport, Iowa office, and Des Moines are the two that are in Iowa itself. And so you put all these together, and not only can you see weather on a big scale like a frontal system, this was from April 2015 with a line of storms, but you can see the birds and everything else going on. So we'll talk about how to recognize what's a migrating bird on radar and what isn't, and that type of thing. So really the biggest thing you can see the migration with the radars on the Weather Service radars is really the songbirds, the passerines, the ones that are in large numbers. They're in loose flocks. They kind of fly in communication and sometimes coordination with each other, but they're not in a big flock like a flock of redwings or in a bee like a bunch of geese. They're kind of just loosely moving through the air all through the night. And so that's what we're looking at mainly with the radar, is a lot of the smaller birds that are in the biggest numbers. So you're not going to see permanent residents because their motions are pretty well random, and the radars are kind of designed to screen out random motion or a single object. So one golden eagle soaring over your house is not going to show up on the radar because the radars are designed to filter out airplanes and single objects like that. So it's going to be groups of birds, really, and the more of them and the more spread out they are, the better. Sometimes you can see raptors if they're like going down the Gulf Coast of Texas, and a lot of broadwing hawks, things like that. Swallows or day migrants, they might be part of what we call ground clutter. We'll look at that. But really, you're seeing the birds that are migrating at night and mostly going in the same direction. That's what the radars will pick up. And so got a bunch of web addresses. I hope you got your email that had the website, so you don't have to try and write all these down. And if you didn't check that, the notice email should have the links, and then they're all pretty helpful. So we're going to look at ways to monitor the weather, look at forecast charts, and I don't really have good answers for a phone app. If anybody has ideas, we can talk about that as far as phone apps that you might use for hooking up between monitoring and migration with radar and birds and things like that. There are plenty of websites you can look at on your phone, and that's how I do it. So another thing we're going to try to do is help you understand when you can predict when there will be more migrants landing in Iowa, so you can go out there and watch them than just the general daytime, and things like, you know, big migration ahead of a cold front or a stationary front. Just like the fallouts on the Gulf Coast, you can have a fallout of birds right here in the middle of Iowa if they're flying north at night and they hit a line of thunderstorms and they land because the weather was bad. They could be right in your backyard. So that's kind of what we're looking for. So just some general things on the weather. You know, could take years teaching a weather course, but the big thing is to understand wind flow. And so in general, the wind wants to flow from high pressure, where the air is typically descending and, you know, kind of spreading out from the high pressure to low pressure. But there's two things that affect that. The winds just don't blow straight from high to low. You know that from just living and being around as long as you have. The number one, the earth is spinning, and that causes the winds with time to adjust, and they kind of want to flow. We have the white lines here are pressure lines. The winds with time will adjust from going straight from the high to the low to kind of wanting to go around the high and the low. So it's kind of a little confusing, but the winds then, they want to kind of follow these pressure lines. We call them isobars. But then we also have friction effects from the ground and trees and grass and houses and buildings. So that kind of bends the wind back. So first the wind wants to go from high to low, then it wants to follow kind of around the highs and lows. And then friction wants to turn it back. So it's a little confusing, but basically if you look at a pressure map like this, the winds are going to converge toward the low, generally following around the way the pressure lines are, and they'll diverge out of the high pressure system. So you got this kind of flow like this going on. And if you got a high pressure out over, you know, the southeast US or out into the ocean or down in the Gulf of Mexico, you start to get winds coming across the Gulf of Mexico and up into the Mississippi Valley, and pretty soon they're up our way. So that's the flow that the birds are wanting to follow during spring migration season. So this area here would definitely be fair weather for migration, because normally you got clear skies and nice weather in this part of the high and low pressure systems. If you get farther north, it's probably good for migration, but sometimes you get clouds, storms in this region. We call it the warm sector of the low pressure system. And you could also have, with a lot of moisture, you could have foggy conditions or clouds at low elevation. The birds wouldn't want to fly into that. And then you get up, this in the springtime would be a warm front through here. So you got warm air to the south and the colder day, kind of like we've gotten into, at least central Iowa. I don't know if Iowa City got really chilly yet today, but we were kind of clammy and rainy today. So that's the kind of thing north of the warm front, and birds typically don't want to migrate in that kind of weather. So any questions on all of that to start out? Okay. So now you're gone from general wind flow around pressure systems to your bird. Well, what do you want to do if you're a bird? Kind of obvious, but you want to get north in the springtime, and energy is a limiting factor, obviously. So you want to not expend a lot of energy. So you would want probably to have a tailwind. If a bird really was thinking about it like that, that's what they would think, but I think it's more instinctive for them. But so they're going with the tailwind and they want to get there safely, so kind of fair weather. So I don't know how they sense it, but they know at the end of a nice day when the wind is in the right direction that they're ready to take off and fly if it's the right season. So that's kind of waiting till the high pressure goes by, the winds turn around to the south or southeast, and they use that. The flow is, clockwise around a high pressure system, counterclockwise around the low. So they catch that and they come up ahead of the low pressure system before all the moisture and the weather comes in with the storm moving in and the cold front. So that's kind of what they're after there. So a good spring migration pattern where you'd expect heavy migration is kind of in this warm sector we call the storm system. So we'll have one of these coming out tomorrow. So there's the low, and you got the little white lines going around it. So you got the high pressure down here. So here's the wind flows generally like this. And so this is when birds would be jumping off the Yucatan Peninsula, parts of Mexico, and heading across the Gulf to come our way. And once they get to the coast, they just keep on coming. It might be a matter of days, but then they'll fly until the weather conditions get bad, or they flew too long for the night and it's time to rest. So that's kind of a good migration pattern. The high pressure coming into the low pressure. And this is one of the charts we'll look at a little later from the University Center of Atmospheric Research that has a nice quick look chart, they call it. I really like it because it shows you the low pressure systems, the fronts, and the expected precipitation. And it's really nice these days. They got rain in green, snow in blue, so you can tell what the weather is going to be while you're looking at your bird migration forecast too. And the birds want to have a tailwind, basically. So in a strong wind, it'll carry them quite fast. It needs to be kind of in the direction they want to go. Otherwise, they get carried off course. And, we all are familiar with stories of that where birds get blown off course by bad windstorms. And sometimes we'll get birds from more of the central plains blown into Iowa sometimes, or hurricane birds coming up, that type of thing. So the smaller you are as a bird, of course, obviously you can't crab into the wind or fight the wind if you're a small bird. So that's important. But if it's lighter winds and the weather's good, the birds will fly the direction they want to go. So let's say the wind is light from a southeast direction and they want to go north, they'll still go north by turning into the wind somewhat. And the light headwinds have less effect when they're motivated, I call it, which is big spring migration, or if they've been held up by bad weather for several days, they're ready to go and they'll take off anyway. And there's another thing in the weather that really affects how the storms develop over Iowa and for the birds too, and we call it the low-level jet. And especially in the spring, this is very active. And in the simplest terms, the wind during the day, this is with height, so this would be down near the ground, and this would be up, say, 2,000 feet, the top arrow. During the day, with the heating from the sun and the mixing of the air, the winds are fairly uniform as you go up with height. But at night, as the surface of the ground cools off, that causes decoupling, it's called, and the winds don't mix down to the ground as much. So that means you got the same amount of air wanting to go north, so it ends up blowing faster up at 2,000 feet than it does near the ground. And this phenomena happens night after night, and it's also partially governed by the sloping of terrain through the plains. It's very gradual, but you go from the Mississippi up to the high plains and the front range of the Rockies. That is tilted, and that all plays into this. So the low-level jet kicks in. Not only do the birds like that because it's a nice fast tailwind up above the ground, but it also affects our storm development and things like that, where a lot of times we get storms developing at night here, and that's because this low level jet kicks in after sunset. You got more moisture and heat and humidity coming up and might be hitting the front or something, and that's what feeds our big nighttime storms here in Iowa. So that's a quick description of that. But so it's a south wind is this low level jet, and that's favorable for the bird migration too. And here's the graph. Since weathermen like graphs, I thought I'd show you one. So you can see at noon, the wind speed was roughly, let's just look at the lowest, 3 kilometers, 10,000 feet. Wind is fairly similar in the blue line. After sunset, these two brown and green lines, you can see the wind slowed down near the ground, and it speeded up here at about 1 kilometer, so 3,000 feet. So that's a picture of the low level jet right there. Faster wind speeds there and more evened out above and below. And there's lots of other reasons birds would migrate at night. And, we could have you throw out ideas, but, they have this low level jet. There's less turbulence at night due to the, thermals from the sun and the clouds. The predators can't find them, so that's good. Temperatures are cooler and more constant, so, their body functions better, I guess. And if you're a bird flying half the night, you got to eat sometimes. So daylight to feed, that makes a lot of sense too. So a lot of this migration starts to kick off about a half hour after sunset, and that around an hour after sunset, if you want to watch migration in action, that's the time to start looking. Typically it peaks around midnight. Not all the birds want to fly all night long to get where they're going. And if they are still flying, you can see a mass descent of the birds at sunrise. The radar signature will just kind of all of a sudden go disappear. So we'll take a look at all that. So like I said, if you got weather going on, that could cause a fallout of birds. And we're all familiar with the Gulf Coast fallout, but it could be caused by not just reaching the coast and wanting to land, but you could be flying into bad weather. So if they're over Iowa and the weather turns bad, they can land if they want to, and that's what they do. So sometimes the birds will be hitting rainstorms, headwinds, even like I said, clouds that are hanging really low. They don't want to fly in that, so they'll land in that kind of weather too. So what really works best for this is when we have one of those east-west bands of thunderstorms, and the birds are flying from the south, and they come up and reach that, and they're landing. So I can think of a day, couple 3 years ago, all of a sudden we had a bunch of magnolia warblers in early May because they hit a bunch of storms during the night, and those magnolia warblers were around my backyard for practically a week, I think. So they got hung up after that. So that's the kind of thing we like to see. But here's a website, woodcreepercot.com, and it's a really good resource to learn about how weather and all this stuff affects the migration. So the author of that, Dave LaPumla, he's now director out at the Cape May Bird Observatory, and he's not updating this, but if you go on this right side and go way down to the bottom right, way down there, you'll get to where he talked about things happening during migration in association with weather back in the 2000 to 2013 range, I think. So that's all in there, and it's a good way to learn. So the Gulf Coast fallouts, were pretty familiar with those. The birds, come from Mexico and head out over the Gulf a lot of times, and so sometimes they'll hit headwinds and whatnot off the coast before they get there. So then they're really struggling to make the final distance to the coast. So they land on the first place they can see. So that's kind of down there. So they're doing the same thing, except they have the restriction of they can't land over water there. So they come in, they land in And, famous places like High Island, Texas, get a lot of birds, and they also have a lot of birders. So if we get a fallout in Iowa, you don't have the crowd to deal with anyway when you're out there looking. So this would be a good pattern for a fallout in Iowa, where here's our constant pressure lines again, so you can expect the wind to be coming around and going like this up toward the low pressure system. If it hits storms here or the front, that would be where the birds are landing. And so, if you're getting a good indication from the weather on TV, or you're looking at things on the internet where the storms are supposed to be, and you say, hey, there's supposed to be some stationary thunderstorms tonight or slow moving, that would be a good night to get some birds landing in your yard, especially second half of April and into middle May. So now we'll switch gears, unless you got any questions for me. Check the time here. So tracking birds on weather radar, it's actually been done since they first came up with weather radars, which were in the 1950s. And so it was interesting back then. They used radars similar to a weather radar to try and get some quantification of bird migration. Then everybody forgot about it, and they came out with the new NEXRAD weather radars in the Weather Service in the 1990s. And as soon as they fired it up, I was working at the Severe Storm Center in Kansas City at that time. As soon as they fired it up, I said, oh man, you can see birds on these radars. What birds are there? I was new to it too, but so that was all kind of interesting. And so pretty quickly became clear that you can see migrating birds, and that's this blue area on here is all migrating birds at night on the weather radars. So all of a sudden, ornithologists and biologists and everybody started doing research using the weather radar to track bird migration. And on the flip side of that, the weather community wanted to get rid of this echoes on the radar because it was messing up their view of the data. So that's how things kind of got started. The first radars, you can see the little graphic here, the pulses were in a horizontal plane. So that was good because raindrops, when they fall, kind of end up getting shaped like a hamburger coming down. They're not a circle, they're not a teardrop shape, they're kind of a Big Mac shape as they fall. So that's wider than it is tall, basically. So it's going to see more raindrops. And then with the Doppler radars that you hear about and NEXRAD, they added the vertical pulse, which allowed you to figure out precipitation type and all kinds of things like that. So, and it also allowed to figure out what the birds were doing and where the birds were on the radar scope.
Karl, you had a question, I think, for the previous slide. What is a stationary storm front?
Okay, stationary means not moving. So a lot of times with weather, it doesn't mean that the storm just sits there, but the front or the band of activity itself becomes stationary and doesn't move north or south pretty much. So in our part of the country, a warm front would usually be moving from south to north. And so that's why we call it a warm front, as you go from colder to warmer weather. The cold front is bringing in colder air, so it would typically move from the northwest or something like that to the southeast. So a stationary front is usually a warm front that kind of meets resistance and stalls and just kind of sits in the same general area. So by not moving a lot, you can have, that's the weather pattern when we get a lot of heavy rain, where you get night after night of storms. So it basically just stops everything and quits moving.
And what do the birds do? And what do the birds do when they come up against something like that?
Well, if they're migrating at night, if they hit bad weather, stormy, low clouds they can't see, or bad winds, they'll land. So they come down and land. It's kind of hard to believe, but they do. We got friends who live outside of Ames on a farm site, and they've had blue-winged warblers in their backyard because they landed in the trees when it was bad weather at night. So those kind of things can happen.
All right, thanks.
I'll go back here. So this is another one of those composite charts, and got something on top. I can't see my top of my slide anymore, but that's all right. So this is all composited together. So during migration, migration season, which is really starting now, anytime you have basically nice weather with south winds, you're going to have migration going on, and you're going to be able to see it in the radar. So that's all these radar sites again. You can see the green and the yellows on here, and we'll show closer pictures. That's the showers of rain and the thunderstorms. They're typically in that green, yellow, red color on the radar. The lesser echoes are usually gray or blue, the way they color them. And a lot of that would be migrating birds, especially if it's a smooth circular pattern that kind of has a bullseye look to it. So this wind information can be derived off the radar too by tracking which direction the raindrops or the snowflakes are moving. But if you got birds in good numbers in there, it starts tracking how the birds are moving. So that's when the meteorologists call this contaminated, because all of a sudden, instead of the wind moving at 20 miles an hour, you've got the wind looking like 30 or 35 miles an hour, and it's birds flying. So that's all interesting. So with a lot of things, it just takes experience looking at the radar data to become accustomed to what you're seeing. So rainfall precipitation is typically fairly blotchy looking. So we have different kinds of rain. You hear stratiform rain. So if it would be an all-day light rain, it would be a pretty smooth color. But if you got showers and thunderstorms in there, which are heavier areas and bursts of precipitation, then you get up into the yellow and the red colors. And if you're into yellow, you probably got enough rain to get you good and wet, and red would be a downpour. So precipitation tends to be kind of blotchy, and you can see it moving in a weather pattern, whether it's swirling or moving off to the north or east. Then you have other things that are a little harder to tell, called ground clutter, which is things that the radar is sensitive enough close into the radar itself. So this is the circle here is 50 miles out from the Des Moines radar. And so it's going to pick up things like maybe some buildings, some trees, echoes bouncing off of those. So that's what gives you this kind of light colored blotchy area near the radar. And then we have wind farms in Iowa now too, and that's what these brighter colors. So if you would loop this picture, you could see that these areas aren't moving, and you would say, oh, they're not rain, they're the wind farms, and you learn where they're at too. So those are kind of some things. So if you want more examples and learn more, go to birdcast.info, and they have kind of a primer on using weather radar, plus a lot of other great stuff that we'll look at here in a little bit. So now we have examples of bird migration on radar, and most of these are kind of in the late evening when the birds are migrating, and you can see the echoes are still close in to the radar, but they're a lot smoother looking. And the one on the right looks like it's thunderstorm red, but that's just the way this one was colored. So most of them are colored like the two on the left. So this is a bird migration echo, and number one, you can watch it develop after sunset. If you loop in time sequence, it just kind of blooms and goes whoop, and blows up out there, and it's fairly smooth and kind of in general a bullseye shape. So that's the bird migration in a smooth pattern. And with the new radar data, you can actually click on a product we'll look at later that'll tell you that these are biological targets. It even picks that out compared to a weather target. The radar can also tell you something about the altitude of birds because the sampling pattern is like a cone. So there's different elevations that the radar scans. So you got these different cones kind of all stacked together around the radar. So in this case here, it's a little bit less echo right near the center of the radar, the lighter color or even no returns, and heavier around. And that means that the heavier around is looking at a higher elevation. So the picture here is kind of, and all the black dots would be birds flying. And what you're seeing is the birds are kind of flying above the surface, maybe a couple thousand feet up, and there's not too many down low, and that's why you get this donut look, we call it. And you can also look at that when snow is moving into your area too, because sometimes there will be a donut around the radar and it's snowing aloft, but it's evaporating and it's not reaching the ground. So that's another sign that, you know, precipitation's aloft, just like birds. You got that going on. You can see all kinds of things. Bats leaving their roost. If you look at Texas radars in the summertime at sunset, you can see these rings or circles and they expand outward, and that's the bats taking off from their roost and heading out to feed. Kind of very similar with birds leaving a roost. This was in Kentucky, but all these circles are, they could be purple martins or blackbirds in the migration season. They roost in their favorite spots and then they take off when the sun comes up and fan out. So you can see these circles expanding and moving around. Pretty fascinating. Here's an example of a big migration night, April 2004. So in this case, the red is a bunch of isolated thunderstorms that were moving across, and all around that we had bird migration happening. So it must have been a south wind throughout the upper Mississippi Valley that night. So these are typical signatures of bird migration. You got that smooth pattern that turns into a bullseye of higher intensity. And, you know, every one of them has something looking like that. So birds were migrating over a widespread area that night. Here's one, let's see, April of 2015. And this is a map you can look at. College of DuPage is in Illinois, and they have a lot of great weather stuff to look at. So I use them a lot. And so this is a case where pretty much all the blue on here was bird migration in progress at that time over much of the eastern half of the US. So you can see all that develop and keep on going through the night. So can you see the top thing that says College of DuPage? Yeah, okay. This is a really good site, DuPage, over in northern Illinois, and they have free weather radar, and you can look at everything a meteorologist of the National Weather Service can look at on the internet. That's just pretty amazing. So basic things you can look at, typically with a radar, they call it reflectivity. It's basically how much energy is bouncing back to the radar from the pulse it sends out, hits a storm, sends back a lot of energy because it's intense precipitation that gets turned red, and lesser energy returned back in the clear air is probably birds in this case here. There's also velocity that you can look at. We'll look at some of that in a little bit. Correlation coefficient is a big thing, but it's basically looking at differences in energy between the horizontal pulse and the vertical pulse. And they now have algorithms running within the radar itself that comes up with a classification of precipitation. So over here they have little print that tells you what's what. So I think green would be rain. And anyway, this rusty red color is called biological targets. So in this case, a lot of that stuff was birds, or sometimes bugs will show up at biological target too, like if you got a lot of moss in the air in the summertime type of thing. Well, those are examples of stuff. It's just too much to cover, but things you got there at your disposal. So here was an example. And so this is down in Texas. Doesn't matter where it is. It could look like this anywhere. So this is the reflectivity, and that's the energy bouncing back. So what are we seeing here? Well, we'll pick out the most obvious thing, the red and the yellow. This is a line of thunderstorms up there. And so that's bouncing energy back. Then you got this arc right here. A lot of times, thunderstorms will put out a cold rush of air, the downdraft. So the gust front would come out from those storms. You're all familiar with that. So that's this here. So that's pushing out away from the storms. And then you got all this going on south. So it's pushing into bird migration at this point, because there's that smooth signature. Got to know where the radar is. There's the radar in the middle. So around there, so you got bird migration, birds running into a gust front coming out of a bunch of thunderstorms. Over here is velocity. Velocity is more difficult to interpret because it's only velocity, if you think of the spokes on a wheel, it's only coming toward the radar or away from the radar. So it's much harder to figure out. But so here's the radar. So we'll look down south here first. And the brightest green is moving toward the radar. So we have a south wind moving toward the radar here. Over in this area that was before this gust front, it's moving away from the radar there. So we use that to figure out we got a south wind anyway. And you can look at different depictions that'll tell you that without having to figure it out yourself. But then you get up here with the storms, it's also moving toward the radar. So you got the south wind where the birds are migrating, and you got a north wind pushing out of the storm. So the birds flying into this are going to say, hey, I don't want to fly into that. And they're going to stop and land kind of in this area. So it's a thing that takes a lot of experience, just like identifying warblers or sparrows or something like that. You got to just practice it and you'll get good at it pretty quick. So here's a loop after sunset. And so you start out, we'll just look at the Kansas City area. You start out with not much echoes, and within an hour, it blooms into this bullseye pretty quickly. And that's the bird migration takeoff, I call it, the after sunset, when all those birds are launching and starting their flight for the night. So it's amazing how quickly it fills the radar in many locations. And you can see quite a few different things too. If you look up here north of Des Moines, there's more birds starting out right at the beginning of the loop over the rivers that go up out of Des Moines River, the Raccoon River, because that's where the trees are. And you can see migration here south of Des Moines, and here's one of those gust fronts right there with north winds, and there are less birds north of that. So these birds coming in landed when this gust front hit them. So you can look at big picture views of this, or you can look at individual views and kind of get that figured out. Up here in the north, so this was a slow moving cold front coming down. The winds weren't favorable, so you can see up here you don't have those signatures. There wasn't any bird migration going on up there. You can also see signatures in the fall, not just the spring. And the birds don't have a low level jet in the fall with a north wind because the slope of the Great Plains is the wrong direction, but they still get plenty of days and nights when they can fly. They're not as really motivated. It's more leisurely pace in the fall, but you still see migration signatures. This was a fantastic one. Beside, I can't remember the name of the hurricane now. It's up there. Blocked out on my picture. But here is the hurricane down off the coast. So, a lot of times hurricanes happen in a weather pattern that gets stalled, and the hurricane itself kind of stalls the weather too. And so we had a lot of birds ready to migrate, but they were waiting for the hurricane to pass on. And so once it went by, you had bird migration all the way from Duluth to the Gulf of Mexico. Pretty amazing. All of these round circles are signatures of bird migration at night. Here's an example of the cold front. So this is the fall, so it's kind of flipped upside down from what we see in the spring. So you can see the loop starts before sunset. So you see first it shrinks near the radar here. And that's probably some of the bugs in the daytime birds, swallows and that, going to roost. And then behind the front, right here, this little line, there's no rain or anything with it, but that's a wind shift line to the northwest. And behind that, you got a bunch of birds take off and fill in the sky. So they're migrating behind the cold front. We're out ahead of it. There's probably some, but far fewer in number. So that's the kind of thing you can see too. Here's an example of the wind farms. They look bright, but there's absolutely no movement whatsoever. They just sit there. This will be easier to see in a loop too, but you got the Texas coast, and you got probably broad-winged hawks and big kettles, a bunch of kettles moving down the coast. So once in a while you can see ribbons of that. They kind of line up with the ribbons of where the wind circulates and gives you thermals and clouds and things like that. So here's an example of off the radar, Weather Service radar. I'm kind of mad at my own National Weather Service at the moment for the way they did their radar. They used to have some really nice, easy to get to regional mosaics of radar, and now you got to go through a whole convoluted process. But this was a couple of nights ago when we had storms down in Texas, and we had bird migration going out ahead of this. So here's these rings. They're a little bit loose and low intensity because it's still March. There's not as many migrants, but all these rings around radars here are bird migration in progress. Just a couple things to look at here while we're on this. Now I'll show you through the radar page, but on the Weather Service website, you'll have a link where you can click local radar. If you want to get to a view like this, you got to click these little boxes in here. This ain't easy. Then you got to click on, it gives you a menu. You got to click on National Radar. It'll give you a radar, but now they're working to help the people wanting to look at radar weather to not have this bird migration stuff. So now they have a quality controlled radar product, they call it, that takes out the bird migration. So if you're wanting to look at that, that's not helpful. But if you're wanting to look at where the storms are, makes it easier to see. So now then you got to go down into this menu and click raw. This is reflectivity raw, and that'll give you the bird migration. So that's in your notes too, how to get to that. University of Wisconsin, Madison has some really fantastic, beautiful radars to look at, and that's a nice one to go to for a quick look. And this was a couple nights ago, or no, this was this morning. So we had some migration overnight last night, and this was kind of right at sunrise when the migration signature was shrinking back down. So it looked like a decent night for migration in the Quad Cities radar and even over Iowa City. So I don't know if any of you are out birding this morning, but there should have been some new birds around. And there's a guy, I don't know him or where he's at, Paul Hurtado. He's put together a nice little web page here. And so if you missed the radar spectacle or you want to see what went on last night, you can go to his web page, click on this, and it'll give you a loop from yesterday at 3 p.m. all the way through today. And so that's really nice because you can learn and just be awed by the fact that how often the birds migrate and over what big areas. So this is a nice one. And you can loop this as well, so you can see the sunset go by and the birds taking off. It's really nice. There's another one on this UCAR website where if you click radar, you can set up this menu here. So you want to do reflectivity, a black background. If you want, you say, oh, I saw a bunch of birds all of a sudden 2 days ago. I want to see what the radar looked like. You can hit this menu here and go back a few days and make a loop and see what the bird migration looked like there. So once you get all that set up, you'd have to do a loop here and do it for several hours or something. Then you just click on whatever radar site you want there, and it'll show you your favorite stuff. Birdcast. I hope you're all familiar with Birdcast already. Have you seen and heard about that? Hopefully, yes. If not, this will be your new best friend. So Birdcast is the Cornell lab and a bunch of researchers and radar ornithology. That's actually a kind of a school of thought now. And they've done their research. They've combined radar observations with field reports to come up with migration. So number one, they have live migration maps. So if you're not good at interpreting the radar or whatever, you can just go to this and they have it done for you. And we'll take a look at examples here. So you have current migration going on, and you also have the migration forecast, which is really nice. So they've combined, years worth of weather data and radar data to say this is from a few years ago in April. We'll look at the current one. The yellow areas are where there's going to be a lot of migration tonight, and it's really pretty good. I mean, Doug Haar and I use it all the time to decide when we're going to go out birding. And they make it migration forecast for 3 nights, so you can plan ahead if you want to. So here's this real-time migration tracking, and it's an example again from April, but it's really nice because they show you where the migration is occurring. So the black areas, no migration. The blue areas and the intensity goes into white if there's really a lot of migration going on. Shows you that, and then they have arrows of what direction the birds are flying. So it's really quite fascinating. Like you can see where birds coming up the coast of Texas would fan out, and some would head east and some would head straight north. And really, really amazing. And so that loops through the whole night. So they have a line move across that shows you where sunrise and sunset is, and it's pretty neat. Here's an example of migration forecast, and so they're predicting this 3 hours after sunset and basically around midnight. And so the intensities are basically how many birds they think are going to be crossing a line moving north. These areas up here also show where precipitation will be. So you can use that to see if you got the heavy migration and precipitation north of it, you could have one of those fallouts at night over your area. So we'll look at the live one of that here in a while. So here's the precipitation examples too. So the white lines and the gray, that's where it would be raining at midnight. Some other sites, and we'll go through these pretty quick because you just really have to practice at it. The National Weather Service, if you pull up this page and you click over Iowa City, if that's where you want the forecast, it'll give you the forecast for Iowa City, and it's all right there for you. They got kind of a little story here on the weather, and if you click in here on local radar, you can get a loop of your radar, but they really mess with it too much and it's not working too great at the moment. And way down in the right, oh, I have to go back. So if you keep scrolling on this page, you'll get to, whoops, we'll get there. Okay, so if you click on your site, you'll get the words and all that. You'll get the words here to go with it, and you come down to this graph here below the satellite and the radar. That's gives you a detailed forecast. So if you're looking at the winds or something, where you're going, or you got a field trip plan, this is a nice place to click. And it's way down there, but it gives you some good information in graphical form by hour. So here's the radar. Once again, we'll explain that. So if you click on local radar, you get this menu. To get the national composite, you got to click the squares, national radar, and go to that raw. So that'll get you some radar. Getting numerical model data is really nice if you like, if you're just a fan of the weather and you want to see what the wind direction is. But their websites are kind of for weather geeks, and they take a lot of clicks to get where you want to go. But one example is the National Center for Atmospheric, the operations of the modeling that the whole country uses. The TV loops of the models of their weather coming, they're all from the National Weather Service. So you'd want to click North America, and the NAM model is good, or the GFS model is good. You don't have to pick any one of those, and then you can get a forecast of 10-meter wind, so the wind 10 meters off the ground, and precipitation. That's a nice, easy one to look at, and it gives you charts that look something like this. So these are wind barbs on here. So they're kind of like an arrow. So the wind is blowing from the flags on the arrow here to the point. So that would be a southeast wind over the Gulf of Mexico. And the speeds are by the number of barbs here. So the little ones are light winds. The more you get, the stronger the wind. That would be 20 miles an hour. And you got the wind, the isobar pattern around the low, and you got the precipitation in green and blue. So kind of gives it all if you want to look at that kind of thing. And you can look down to the Yucatan and say, yeah, the birds would probably be flying tonight. They're taking off. Fair weather over the Gulf, southeast wind, away they go. And they even do a simulated radar map now. So that would make you, if you want to enter the fantasy world and see where storms might be at such and such a time. But remember, it's a computer forecast model, and they can be wrong just like people can be wrong. Simulated radar, that's what it is. So that's what the TV people are using now when they say, here's the forecast for today and when the timing of the precip. That's what they're bringing in. As far as apps on the phone, I've tried Windy TY, and it's the same as the windy.com website, I think, and it's really got a neat map of the wind field. So you got this slider bar on the bottom that you can move across, and you can see what the wind direction and kind of speed is going to be as you move across. And it's really nice to visualize without having to be a weatherman and figure out how to get the chart you want. Their radar is good radar data, but they're quality controlling it. They're taking out the migration signatures. So if any of you know of an option for raw radar on your phone, other than going to a website like I do, I'd like to hear it, because otherwise we're basically using websites on our phone to see radar in that way. Here's that UCAR website, and if you click the forecast tab here, you can go down here to these quick look charts. They're really nice. They're quick and easy to use. If you want to look at radar, that's the tab there, and you get some radar data. So here's the quick look chart for tomorrow morning. Big debate on whether the snow is going to actually happen or accumulate up in this area. So that's what the blue is, where they think it's going to snow. So that's a quick look. And you can also look by following these white isobar lines. You can follow where the wind generally is going to track and see that there's probably going to be some migration. If there's Gulf migrants wanting to fly as early as mid-March, hummingbirds do it, I guess. So maybe some hummingbirds taking off tonight. So I would encourage you to try and make your own forecast. And if all else fails, you can go to Birdcast and do it that way. So with that, I think I'll jump out, and if you got any questions, be sure to toss them out right now, and we'll look at a couple of live websites if you'd like to do that.
If you have any questions, just go ahead and unmute yourself and ask Karl whatever you want to ask. Karl, I want to ask kind of like a basic question, like back from the very beginning. When you've got the weather, like the rain, the radar shows the rain, say up in northern Iowa, the birds are not going to want to be flying into the rain. So are they going to be hanging out in below, like south of that weather pattern?
Well, in general, they don't want to fly in rain, but they do if it be light rain or something, or a lot of it depends on how high the clouds are up or if they're close to the ground. But I don't think they're looking up there saying, oh, it looks like thunderstorms. They're kind of experiencing it. So if they get into it, that's where they would land.
Oh,
so,
okay.
So
okay, that helps. Okay.
Like today, this is current. It's raining up north of you guys. So a bird might be flying and just say, well, I'm well fed, I'm ready to go. So then they might just take off and fly, but then if they hit the bad weather, they would stop then, so that's kind of my interpretation of it anyway.
Okay, thanks, that helps.
So here's a case where this is the Quad Cities radar and Iowa City's over here. So they're the closest radar to you. They're kind of outside of their ground clutter pattern. You can see this little light stuff. So that's typical ground clutter. So I don't see much evidence of bird migration going on here. So we can flip over to velocity data and see what direction the wind is from. Oops. So we just have a little bit going on here. So we don't have much even to give us a velocity signature. You can see up in the rain, the winds here are moving away from the radar. So up in the rain level, you've got a south wind, but down near the ground, I don't know if the wind has shifted yet or not. So that's what you can use once the birds start flying. So we could jump out and find some place where there's birds. So the way to do that, so you're on your local radar, is this little funny looking map with a pointer on it. If you roll over that, you get radar selection, and you click that and you get the whole country. So then we can look at all these different radar sites, and whatever one you click on, it'll show it to you. So we'll pick St. Louis. So here's the radar. You always find the radar by the center of the circles or the black dot. This is velocity now. Green is toward the radar. So your winds are coming from the south, crossing the radar to the north. So that's probably a lot of birds going on right there. If we look at reflectivity and loop it. Well, this is somewhat of a nighttime migration blooming pattern. So early on in the loop, you can see closer to the radar, some echoes moving up. It kind of dims out a little bit, and then all of a sudden it starts to expand pretty quick. And that's probably migrating birds taking off there over the St. Louis area. Quite a higher concentration in the brighter colors out here to the west for some reason. If we go down to this, HHC is the classification of precip type. And the whole radar is that funny looking reddish color, which is BI down here, biological. So the radar algorithms have figured out that that's biological targets, which means it's either bugs or birds. So they did a pretty good job on that. So that's that example. Birdcast we'll look at quick.
Carl, I'm going to interrupt you for a second. There was another question. Under what weather conditions is one most likely to hear birds passing overhead?
Yeah, that would be, I think, kind of the same reason birds sing a lot in the morning. Would be probably the second half of the night and toward morning, because you get the temperature inversion near the ground, and usually that's when we're kind of quietest outside because the wind calms down, because the wind is blowing up over our head rather than mixing through the trees and stuff. And sound carries really good in those conditions because that temperature inversion means it's cooler near the ground and warmer aloft. So that kind of bounces some of the sound down your way too. So I would say later at night toward morning would be the best time. And obviously a night when there's really good migration too. The more birds you got flying, the better. And sometimes it's hard to tell what altitude the birds are at, but for some reason the birds would be at a lower altitude that night, and that's really, I don't know how to predict that. If they were lower altitude, obviously you could hear them better too. Does that answer the question good enough?
Yeah, Liza, unless you want to follow up with that, but yeah, thanks.
That's a good question. So here's the Birdcast website. And so we'll go to live maps first, which is down here. So here's the live migration map. And the red line is sunset. So if you click on that, I think it gets bigger. I don't have a fast internet connection, but they have a nice scale over here that shows you the degree of migration. So black is none, blue is low, blue into purple is low, and if you get toward the yellows, you're starting to get more. So I picked a good site there at St. Louis. They're showing getting toward medium migration, and they have a direction now. So all this area is where they are picking up migration based on their algorithms, and you can loop this and watch it progress through the night. It's really a fantastic tool. And here's the, oh, now I gotta go back. Then we have the forecast charts up here. So the forecast of migration works kind of the same way on the color scale. So they're predicting decent amount of migration, kind of the mid-Mississippi down into Texas, Florida, up the Ohio Valley, and some rain in here. So pretty good migration night the way it looks in here. If we look ahead in time, so this is Friday night. After that weather system, we wouldn't expect much migration with the north wind. And then Saturday, the winds come back around. So they're predicting a pretty good migration all the way up through the plains on Saturday night. And I would guess Sunday night too. So what else would you like to see? Any more questions? Here's this historical loop of the radar from Paul Hurtado. This was 2 nights ago. Or no, this was last night and this morning. So this indicates that your neck of the woods probably had some birds migrating into the area, and whether they kept on flying and just landed in sporadic areas, or if they hit the weather before the wind shift and landed, it's hard to say. But that's kind of one of the tricky things with migration is, a lot of times you'll see a lot of migration and you'll go out the next day and the birds won't be that numerous. And it could be because they just kept on flying and went right by you, and they landed over a widespread area rather than being concentrated. So sometimes big scale migration doesn't mean you're going to see a whole lot of birds the next day.
Carl, this
Yes.
is David Wise. I've got a question. In these images, the migrating areas, they're patchy, right? That's just where the radars are, right? That the black areas between the blue donuts have birds too. They're just too far from the radar.
That's correct. Yeah, that's a good question. I didn't really explain that. The radar color intensity, the yellow, the red, and the blue is basically how much energy gets bounced back to the radar. It sends out a pulse and then it listens. And so the birds send back a weak signature. I think maybe it's because they're feathered. I don't know. They're made of water, so they do bounce some energy back, but so it's a weak amount of energy, and that's why you're in this lower intensities down here in the blues. So usually what they're signaling is what would be no precipitation radar echoes, or into the green, which would be very light precipitation. But yeah, so that's only can be sensed only a certain distance from the radar. So the black areas in between are where the birds are most definitely flying in there, but they're just not being seen by the radar. Unfortunate for us, northern Missouri and southern border of Iowa is one of the bigger holes in the Midwest for radar data, but we're making do. Good question. The windy is a neat thing. My slow computer, but it'll show you at a given time, and it has a scroll bar here at the bottom. So this is showing us tonight, 8 p.m. We have north winds. You can see the little wind spears going down, and that the front is running from Kansas City up through Peoria, Chicago, and south winds ahead of that. So that's why the birds are migrating through St. Louis, and people along here might have more birds in the morning if the birds decide to land there. So I think I'll stop talking unless you got more questions. Maybe I'll stop sharing my screen unless you want to see something.
Are there more questions, Carl? Are there more questions for Carl? That's what I'm trying to say. All right. Well, Carl, thank you so much. That was really informative. I had no idea.